Welcome to Ask and Learn.
To figure out the radius of convergence, we'll use the ratio test here. So take the limit as n goes to infinity, absolute value of an plus 1 over an. And by an, we mean this whole thing, so including the x values here. So this is limit as n goes to infinity of absolute value of x plus 2 to the n plus 1 over 2 to the n plus 1 natural log of n plus 1. So this is our an plus 1 term dividing by an, so multiplying by the reciprocal. So we're multiplying by 2n natural log of n divided by x plus 2 to the n. So x plus 2 to the n plus 1 divided by x plus 2 to the n. That's just going to leave us with x plus 2. 2 to the n divided by 2 to the n plus 1 is going to leave us with 1/2. And then we have ln of n divided by ln of n plus 1. And to figure out the limit as n goes to infinity of natural log of n divided by natural log of n plus 1, you do L'Hopital's rule here. So both the top and the bottom blow up to infinity, so you can apply L'Hopital's rule. L'Hopital's rule, you do the derivative top, divide by derivative at the bottom, so we'd get 1 over n divided by 1 over n plus 1. So we'd get limit as n goes to infinity, n plus 1 over n, which is just 1. So ln of n over ln of n plus 1 does go to 1. So this is just absolute value of x plus 2 over 2. And we want for that to be less than 1. So if we multiply both sides by 2, we get absolute value of x plus 2 is less than 2. So at this point, you might already be able to see that the radius of convergence is 2. If you can't, the way you figure it out is, if this happens, then x plus 2 is trapped between minus 2 and positive 2. So if minus 2 is less than x plus 2, if we subtract 2 from both sides, that means that minus 4 is less than x. And if we have x plus 2 is less than 2, if we subtract 2 from both sides, we get that x is less than 0. So the length of our interval of convergence is 0 minus 4. So the length of our interval is 4. The radius of convergence is half of the length of the interval of convergence. So half of 4 is 2. So that's our radius of convergence, r. For the interval of convergence, we need to figure out whether or not we want to include the endpoints. So whether or not we include x equals 0 and whether or not we include x equals minus 4. Okay, so if x is equal to 0, then we'd have 2 to the n over 2 to the n. Sorry, the 2 to the n over 2 to the n will cancel, and we'll just have 1 over natural log of n. Okay, but if n is equal to 2 or any larger than 2, then natural log of n is going to be something that's smaller, just regular n. If we replace the denominator with something that's bigger, then we should get something that's even smaller. Okay, so this sum should be larger than this sum. And this sum blows up to infinity. That means that this sum also has to blow up to infinity, so this is divergent. Okay, and then we need to figure out what happens when x is minus 4. When x is minus 4, we'd have minus 4 plus 2, so we'd have minus 2 to the n. So the 2 to the n's will again cancel, and then we'd have minus 1 to the n happening. So when x is minus 4, We plug in minus 4 into here. What we get is the sum from n equals 2 to infinity of minus 1 to the n over natural log of n. And this is going to converge by the alternating sign test. So we do want to include minus 4, but we do not want to include 0. 0 gives us divergence, minus 4 does not. So minus 4, we include that. 0 is bad, so we throw that out.